Welcome to the another video of the solution of the semester question in basic electrical engineering. In this question 1, you have got first is a theory question like define Kirchhoff's law, and then you have solve this numerical. So when you define Kirchhoff's law, you can define it very briefly of like this is 2 marks, this can be 4 marks total, the definition. So Kirchhoff's current law, summation of current at a node is equal to 0. And the Kirchhoff's voltage law, the drop throughout any path, any closed path will be equal to 0. And while solving this numerical, the question is asked to determine the current in each loop using mesh analysis. So you have how many loops are there? You have got 1, 2 and 3. 3 loops are there. You can have 3 different meshes, and you have to take the number of loop in such a way so that all the elements are considered. So let us make it very simple. So 3 loops are made, 1, 2 and 3. In loop 3, carefully see that there is a current source. So this current source 2 ampere is there only in loop 3. So we can simply write I3 is equal to 2 ampere. We can say this as a mesh also. In mesh number 3, the current is 2 ampere. In mesh 1, we can write minus 4. We can take a KVL in the mesh 1, minus 4, then 2, I1 minus I3. I1 minus I3 multiplied by 2. There is a dependent voltage source, so without any having a worry, simply write the value because first plus is coming, so plus 2i is equal to 0. This is the equation of mesh 1. Done. We can substitute the value of I3 over here and rewrite the same equation. In mesh 2, it is first encounter is minus, then you have 1 ohm multiply with I2 minus I3, I2 minus I3, then with plus 6 is equal to 0. I3 value substitute, you will get some equation like this. So once you have all the equations, so one more equation you need because this current which is this is a dependent voltage source which depend on the current somewhere. What is the current is this I, and this I is nothing but I2 minus I3. So we can write I2 minus I3 is the I. So using I3 value substitute here, we get equation number 4. So now we have 1, 2, 3 and 4. We can use 3 and 4 to get I is equal to 6. This I value is 6, but my answer is not, question is not this, what is the value of I. The question is to get the 3 mesh current, that is 2 ampere. I1 is minus 2 ampere and I2 is 8 ampere. That is the answer. The next question is the superposition theorem, and in this question you will have obviously definition of the superposition theorem. So you can define the superposition theorem that at any point, at any time, one voltage source is considered and rest of the voltage source will be replaced by its internal resistance. So here, this is a question given. So it is like 10 mark question. So theory is 4 and this is 6 mark. So here you have got 3 sources. So let us take 6 ampere. Voltage source is short circuit. This is open circuit. Next we take 4 ampere. This current source is open circuit and voltage source is short circuit. Similarly, next we take 6 volt. The current is open circuit and this current is open circuit. This seems to be very easy. Circuit numbers. See, so let us discuss this first. This is, we can see that here this is 2 and this is 2. These 2 parallel and they convert into 1. And now you have got this 2 over here. So total is 3 ohm. 6 divided by 3 is 2 ampere with the plus sign in from downward direction. Next is here we have B. So let us take this node here, 2 values, node 1 and node 2. So we can write this as node 1 and node 2. and this node 2 is same as node 2 here. So node 1 and this node 2 and this node 2 be same because there is no resistance between them, and 1 ohm is in parallel with it. Node 3 is here. So here you have node 3 is here. So now you have got 3, 1, 2. Between 3 and 2, the 2 ohm is here. Between 3 and 2, this 2 ohm is there. So it is very clear. We can redraw the circuit like this. Now this 4 ampere current has to split between two paths. One is this side, one is this side. On the right hand side there is a 2, this is 1, and this one becomes again 2 ohm. On the right hand side the net resistance is 2 ohm, on the left hand side 1 ohm. So the current which is going towards this right hand side will depend on its opposite resistance, that is 1 divided by 3 into 4. So that is the total current which is going on right hand side. This current is going to split between these 2 points. So the current which is going towards the load will be 2 by 3 but in the upward direction. So the IB is the negative of it, minus 2 by 3. So this is second. This is the current because of 4 ampere. Next is your current because of 6 ampere. 6 ampere is over here. Again we can say that nodes over here, like this is 1, this is 2. So here it is 1, here it is 2. So between 1 and 2, 1 ohm is there. We connected 1 ohm like this. And after 1 and this, let us say this is node 3. And here it is node 3. So between 3 and 2, there is a 2 ohm. Between 3 and 2, 2 ohm. So this circuit maps over here is correct. So now the same 6 ampere is going to divide between these two paths, one here, one on the right. So the one which is going on the right will depend on its opposite resistance, that is 1. The net resistance to here is, this is 1 plus 1 is 2. So 2 and 1 is 3. So the current in the right hand side is 1 by 3 into 6. So that, and this current is split into again 2 parts. Obviously equal. So this is 2 ampere divided by 2 is 1, and now the current which is moving up is 1 ampere, so obviously the down current is minus 1. Now we have the 3 currents here, minus 1, minus 2 by 3 and 2, and if you sum up these 3 it will be 1 by 3. So that is the answer to the second question. Third question is here. The series RC circuit, R and C is given, so obviously from C we can get XC. XC is 1 by 2 pi F, 2 into F is, frequency is 50, it is 100. So 100 pi into C is 120 microfarad, 10 to the minus 6. We get the value of XC here. Z is, we can write here Z also as R minus JXC, and this is in rectangular form. We have to get the magnitude, root over of R square plus XC square. So we get this value, and thus we get Z is equal to 26.826. The current over here is V by Z, that is 8.574 ampere. The power factor is the cos of the angle between V and I. So that actually you can get, you need to know what is the angle by, it is tan inverse of minus XC by R. So that is tan inverse of minus XC by R is the phi, that is 81.42 negative value. Cos of this value is 0.149. While drawing the phasor diagram, the current in the should be in the reference direction, that is in the x-axis. Now you have to multiply the current with the resistor. You have to multiply the current with the capacitive reactance. So when you multiply the resistance, there is no J term, so this will obviously alone along the x-axis. But when you multiply the current with XE, there is a minus J term, it will come downward. When you have a phasor addition of these two voltages, it will come like this, V. So here there is a 5 bits, so each of, you can have 2 into 5, 2 plus 2 plus 2 plus 2 plus 2, like that, 10 marks. Next is you derive the EMF equation of a transformer. So that one can derive, and also working of that single phase transformer you can explain by using mutual inductance, and then you have a voltage regulations, you can write any one of it, voltage regulations. Then you have the power factor. Why we need to improve the power factor of a AC circuit? Some question, this question is asked. So because you can see that the power factor VI cos phi is the active power that is required. So suppose this is 10 watt, my load is 10 watt, and for that I am drawing some current. V is fixed. So the current value cos phi is 0, the cos 0 is 1, so this value, if it is 1, if this is 1, suppose my V value is 5, this value is 2, so 5 into 2 I will get 10. Now if this value of cos phi will be 0.5, so the current value I have to make it 4. So you can see that if the cos phi value decreases, my current value increases for the same load. Thus, if poor power factor is there, it will lead to draw high current from the source, and that high current will have copper loss and other transmission line loss, and other losses will be there. So if you can write in brief that why you need to improve the power factor, it's okay. And how to improve? Using capacitor or synchronous condenser or phase advances. So if you write briefly of some of the points, it's okay, fine. So this can be of 10 marks, of like 4 plus 6, 10 marks. The last question is the armature from the DC machine, where number of poles is given. Lap winding means it is a 2-pole. The voltage for it is designed is 200 volt. Z is a number of conductor is 400, and it is rotating at 300 rpm. So from the formula, the EMF that is the induced in the armature is phi ZNP by A, and flux is not given, so we can put the value of E at equals to V at 200 and get the value of phi. This phi value, we know that E is equal to N d phi by dt. N is the number of turns, over here is 1200. So flux, the final value of the flux is 0, so we can get a total time is 0.1. So from here we substitute the value of flux from here, and then we get here 1200 volt. So this is the solution of the set 1 of the semester question. So see you again for the set 2 solution.